Railway track failure detection, implementation, and maintenance strategy.
So this is the demonstration video of our project. Firstly, this is an aluminum C channel. There are two aluminum C channel that represent the rails. These are the sleepers made up of WPVC, which represent the actual sleepers between the rails. These sleepers are clamped to the rails by means of screws. Then this is the actual crack detection vehicle. This vehicle consists of a base plate, four wheels, two at front, two at back. Then the base plate and the wheel are made up of WPVC, that is wood plastic composite. Then electronics and electrical circuit and components. This is node MCU. This is GPS module. This is a motor driver circuit which drives the motor. This is AC to DC converter, and this is an ultrasonic sensor. So the two motors that are connected to the front wheels drives the vehicle. These are the two motors. This is one motor. Another one is this motor. So these two motors drive the crack detection vehicle. So now I will explain the working. First of all, whenever the power is given to the motor driver circuit gives signals to the node MCU. Node MCU takes signal from ultrasonic sensor that is placed over here. So ultrasonic sensor gives signal to node MCU that there are no cracks, and this node MCU again gives signal to the motor driver circuit. So the motor driver circuit drives the two motors that are placed in front, and the crack detection vehicle move forwards. So whenever the crack detection vehicle move forwards, what happens is that as the crack detection vehicle move forwards, ultrasonic sensor senses any cracks between the vehicle. So these are the crack that we have made. So in the track, so whenever the ultrasonic sensor senses these cracks, it automatically sends the signals to the node MCU, and node MCU then gives signal to the GPS to send latitude and longitudinal information to the real-time database. So whatever the ultrasonic sensor senses, it is displayed on the real-time database, and then node MCU gives signal to the motor driver circuit to stop the motors. So the motor is stopped for around 2 to 3 seconds, and then it start again, and then it continues to move forward again. If there is a crack in the track, the ultrasonic sensor will again sense, and the procedure will be followed again. Now it is a time for test. So whenever the power is supplied to the motor drives the vehicle forward. So at this location, ultrasonic sensor sense the crack and send it to the node MCU. Node MCU again send it to the motor driver circuit, and the motor therefore stop. So again at this location, the ultrasonic sensor senses the crack, and the same procedure follows. Node MCU therefore sends the latitude and longitude value of both the crack to the real-time database. So on the left side it is real-time database. On the right side of the screen it is a live map. So the node MCU sends the latitude and longitudinal signals to the real-time database, and this latitude and longitudinal signal is sent to the web app on the right side, and the number of crack is also detected onto the web app. So in our project there are two cracks. So whenever the first crack is detected on the left side, it shows onto the real-time database, and then also the second crack also will be shown. This is the second crack, and also the number of cracks is shown on the live map and the location on the live map on the right side of the screen. This is a zoom in image of the live map. The two blue dots represent the location of the two cracks that has been detected.